Alright, yeah, we're going to talk about representing number sets, alright? So this might seem a little bit of a not popular topic or something you didn't know you needed, but it's extremely important to understand these notations. You don't need to know all, you just need to know one or two and be able to understand how to write them, but you should know how to read all of them, okay? So the idea is that basically you got a number set and you want to describe it mathematically, and there's shortcuts to do it. For example, instead of saying all the numbers between 3 and 4, there's a way to write it using these number sets. So how you can say exactly that all the numbers between 3 and 4, or 3 and 7, or 3 and 10, or whatever the case is, you can write it mathematically. So the first way, the way I just said it now, is describing a set of number using words. Uh, so that's just what I said. All the numbers between 3 and 10, for example. It's just describing it in words, alright? So that's the basics where we start this off. The next thing we need to know is something called set builder notation. And there's a couple of definitions first. We need to know what this E symbol stands for. E simply means element of, means it belongs to. So whatever is before E, it says that that belongs to the number type that follows. So the number type we usually use is R, or which means real numbers, which includes all numbers on the number line, including rational and irrational numbers. So whatever you are saying, for example, if you said x is an element of R, it means x belongs to the set of real numbers. X belongs to the set of real numbers. X could be any real number from negative infinity to infinity, which could include negative 3,000, positive 7 million, negative 3.5, the square root of 14, the square root of 3, anything that is a real number, whether it's rational or irrational. Now this is how we write set builder notation. This curly bracket, and then you say x colon. Now whatever this is the variable you're referring to. So if you're saying the set of numbers is called or has the name x in this example, then that set of numbers is given, yeah, the name of that is given, yeah, the variable x. Then you put the condition, which means how we're describing. If you want to say between all the numbers between 3 and 7, so you'll put a 3 and you'll put a 7, x in the middle, and this condition. Now this condition means that x is in between 3 and 7. It's all the numbers between 3 and 7. Now because this is not an equals to, it means not including 3. And because this is equals to, so this means including 7. So not including 3 and including 7, all the numbers between 3 and 7. That's the set of numbers we're talking about. And then we specify the number type. So we say that x is an element or belonging to our real number set. So x, these numbers between 3 and 7, including 7, are all real numbers, and that's what's written here. All real numbers between 3 and 7, including 7, which is also represented using a number line. So from 3 to 7, but don't color in 3, only color in 7 because we're including 7. So that's set builder notation. Alright. For interval notation, we have a bit more to understand. Firstly, you have curved brackets and square brackets. It's very important which bracket you use. Similar to how you use a less than or less than equal to sign, a less than means not including this number. A curved bracket means not including whatever number is next to that bracket. And a square bracket means including whatever number is next to that bracket. Alright, then we have the symbol for infinity, and when we use infinity, the bracket next to it is always a curved bracket. We also have an O symbol or an AND symbol. So an empty cup sort of shape is O, and a little mountain shape is AND. Now, here's an example of something written with interval notation. Okay, so here we say x is an element of. That means we're giving it a name. The variable x contains all the numbers that are an element of these points, right? So x is an element of whatever this says. Now what does this say? So we've got a curved bracket because of negative infinity. Remember, infinity uses a curved bracket. So that means starting from this point, from the first number to the second number. So from the first number, negative infinity, not inclusive. So from negative infinity to -1, but this is a square bracket, so including -1. So all real numbers between negative infinity and -1, including -1. Okay, so that's what this portion says. Or, so this says or, so that means these numbers or these numbers. Now what does this say? From 2 until 7, not including 2, including 7. All numbers between 2 and 7, including 7. So this or this is what belongs to this number set, and those are going to be your real numbers. All right, now how does it show in the number line? So this part will have its own sort of directional arrow. So -1 that way just means up until infinity because it continues without end. And this one is 2 and 7. So 2, 7. This not colored. 7 has a square bracket, so we color it in. Right. Then we have inequalities, which is personally my favorite and the easiest way to do it on graphs. And from functions, I just absolutely love using inequalities when answering inequality questions on graphs. It's just so simple. It's one of the easiest ways to write it. In fact, some these ones I've probably like barely ever used, all right, if ever. All right, so let's talk about this now. So inequalities, the first example I'll talk to you about is this. X is an element of real numbers. That simply means that x is all real numbers. Every single real number on your number line from negative infinity to positive infinity, everything. Okay, then we have these. Now these are interesting. So this says x is less than equal to -1. That means x is lower than or below -1 or less than -1. So this means all real numbers between negative infinity and -1, including -1. All right, so I seem to have erased a 7 here. All right, so everything here, everything from -1 to the left. So this is what's shown here, -1 to the left. It's the same thing we've had here, but this is what we had to write before. And I find writing infinity as pointless. And apart from being pointless, I find it really difficult to keep consistently drawing the infinity sign. It's like, honestly, sometimes it's a bit crazy, but this is okay. See, like so it just goes haywire at some point. So I that's why I don't use this. But anyway, this omits that infinity symbol, because when you say less than -1, it means right until negative infinity. So all real numbers between negative infinity and -1, including -1. It didn't have to be including if I took that out. All right, so anyways, that's what that looks like. Or, so the or symbol is still there, but in this case now, so we've got x less than 2 is less than x less than equal to 7. That means x is just between 2 and 7. And one thing, when you've got two numbers and x numeral, these signs always face the left. You don't have to think about it. These signs will always face the left hand side. They'll always face the left, and you'll have the smaller number here and the bigger number there. Okay, so it's always facing the left provided the smaller number is there and the bigger number is there. If for some reason you choose to put the smaller number here and the bigger number there, then they'll face this way. But generally, we always face them to the left, and the smaller number and the bigger number goes there in whatever variable we're talking about. So in this case, x is between 2 and 7, not including 2 and including 7. So there we go. This is what that looks like. It's the same thing we did here, but this was the notation, and this was that notation. This is important because we're going to be using this when we do inequalities with graphs. So you should be able to know how to take anything of this format and write this, and that's what's going to help us in that section. The last thing, which is practically useless, no, well, it's not, it's kind of useful, somewhat arbitrarily important, is a roster or list form. And it's basically when you just have a few random numbers or just a few numbers. So for example, x is an element of -1 0 1 2, but that just basically means x is only including these numbers and nothing else. So x is all the values listed in the curly brackets. All right, so that's the basics on that. If you found this useful, helpful, or even mildly entertaining, drop a like, subscribe, leave a comment.